Okay, so that's been modernized to the current standard.
Right.
Okay. By the way, let me talk about look at those weird bugs there. Let me talk about this, the size of those vertices. Have you gone through with people what is the algorithm we're using for that?
The size of the vertex.
Well, yes.
We have a formula we deduce, which is, I think, proportional to the position of the vertex in the unit box. So,
are you happy with what it does?
Yes, it worked great from small to large one.
Okay, fine. All right, good. Okay. Okay, I'm really glad that we've got these aligned. Okay. And what's your point here, other than that this is possible?
Well, the things that works for small doesn't necessarily work for large.
So you
That's
can
very nice. Now, why am I not seeing this? Is not purple boxed because this is now a graphic because it's graph plot. Is that correct?
It's graphics.
Yes.
Okay. So coordinate tools options. I don't really understand what that is, given that this thing isn't offering me coordinate tools.
Well, so those are the old, graph plot options. So I'm just showing the difference. We still support them, but they're no longer graph plot options.
But I don't understand. I'm saying the coordinate tools options. Why is that?
Those were the old options that you're seeing here. Those are the old options that are no longer options.
Oh, I see. I understand. Okay, fair enough. So that was a way of doing annotation. What is the modern version of this?
Label or annotation wrapper, essentially.
So I see. So if I do this with a labeled wrapper, that's the modern version. Much better. Okay. Okay. So there's a plot theme which you're not yet supporting in the autocompletes.
Correct. But that's just because the documentation needs to be, defuturized.
What does this mean?
Well, that's. So Roger, go ahead.
It's just a name for that theme.
But why is that? Why are there two themes? How are we getting to that before?
So that's first my mistake. The name of the plot theme is classic and the classic diagram. So that's the old name. And
okay,
this is just that.
Classic.
Yes.
Okay. But why is when classic diagram before in the old graph plot? How did you get to that thing? How did you get to the labeled thing?
You do vertex. Vertex labeling goes to true to have the label.
Okay, but why are we calling it diagram? Why aren't we just calling it like classic labeled if we're calling it anything? Because why wouldn't this just be this with vertex labeling arrow automatic? Why didn't that work? Did you understand my question?
Yes, probably, still an update. Something we have to fix, but yeah, it will work. It should work by default.
That's just a bug. So something is wrong there.
Yes.
Okay, so a question from our live stream. If self-loop style is no longer an option, do we still have a way to control the size of self-loops?
Not currently. Hopefully soon.
Ouch. Okay. Why did we remove the self-loop style option?
Because it's...
First, it's not a style. Two, is a parameter, a factor on, essentially, it's kind of hard to control, essentially. It was just a multiplicity of a set of points around that loop.
Okay, what other functionality are we losing here? I went over this too quickly.
So essentially, you can duplicate the self-loop style with vertex shape function. Essentially, you just have to write the right shape function.
How is it? How grotesque is it?
Well, yeah, you have to write some code, so it's not that.
That's not good. So what are we going to do with the page about self-loop style, which is a documented feature, right?
So currently, the plan is that if you put self-loop style, we still return you the same old graph plot. So you are,
I see. So if self-loop style is included, it goes back to the old graph plot.
Exactly. Until
are we going to generate a message of some kind or not? No, probably not.
No.
Okay. Well, what other things like that? What other incompatibilities like that are there?
Just self-loop style and multi-edge style. Those are the two ones.
Okay. And so that will go back to the old. Okay. But so you're going to get. What are you planning to do? Well, I mean, this doesn't look totally stupid here, if I might say so. I mean, maybe it should have been called self-loop rendering, but I think we intended self-loop style to have string names to be able to draw them in, in specified styles. I'm not thrilled that this is just silently going away. I mean, what is the plan here?
I mean, it's not going away. It's just that, even in the new graph, we don't need that because the automation, the whole automation, you don't actually have to bother about the size of the self-loop. Right?
So you're telling me if I were to put a self-loop in here, that I would be happy as a clam about what it does. That is nice. I'm happy. I mean, are you telling me here if I were to,
for sure there is a limit, right? I mean, if you.
So let me just, for the hell of it, let me just add in here, just to be mean. Okay, I'm going to add in here. Oh, actually, let me just go ahead and flatten. That's rather attractive. Let me be meaner. Not bad. I mean, that's unfortunate, but that seems very hard to detect. So this is by default not a directed graph?
Yes, you have to. That's the same default in graph plot that has before. You have to put directed edge goes to true. The default is false.
But is that an option we're continuing with?
Yes.
Oops, what just happened there? Why did it change size? Well, it's not bad. This is really not bad. And so your argument is, I just don't need the that those options are not so important. Why did that not have a smooth edge?
Yeah, so probably we need to do more refinement there for the multiple edges.
But what is it normally? Is it a B-spline or is it something else?
Yeah, it's a B-spline.
That's surprising that a B-spline would have looked like that.
Or maybe we just redraw it as lines.
Shall I send you this example?
Yes.
But this is really looking quite good, in my opinion. All right, so the basic plan for right now is if you have a self-loop option, it will revert to the old graph plots with the idea that there will be some investigation of new self-loops. Yes? Is that correct?
Yes.
Okay, so here, to me, I don't understand why you don't call this like classic labeled.
Okay.
I just don't think diagram, that's a whole nother idea. Oh, well, okay. At least you admitted to that right there. So what is this saying here? So wait a minute, that's doing this, but that's not reverting to the old graph plot. That's just that's ignoring those options, right?
Right. I mean, that's the today build. I mean, we made a change lately where we have to, if you put the old options, we use the old code.
Are you sure that's the right thing to do? Because honestly, the new stuff really looks quite good. I mean, maybe what you should do is somebody on our live stream is asking, what is the limit on the number of on the number of self loops at a vertex? Okay, let's find out. I would say the limit is very large. I don't think there's anything disastrous happening, right? It's just going to keep doing that, isn't it?
Yes.
Why is it necessary to supply the directed edges option when the graph definition already uses directed edges? Yeah, well, for graph, so that is an interesting question, whether we should change that. I mean, that would be a scary thing to change. And I kind of think we shouldn't change it because what's being, the point there is if this was, by the way, what's this? I mean, how do we do this now? This thing here, the vertex rendering function, that would be, how do we achieve this functionality now?
With vertex shape function, and I think pretty much the same option.
But why did we change? I mean, in this case, what we have is graph plot does this, and graph. Why is that different? Why is that different?
Because there are two different graphs, and we pick the orientation, we pick a different layout. Because this is a directed graph, we use a layered digraph to show the structure. Right? We pick a root.
I see. So, but if I were to replace in here, if I were to replace rule with two-way rule, oh, beautiful. Okay, but the issue here is the assumption of whether it is a directed graph or not is different between graph plot and graph. That is a bit unfortunate.
I mean, if you don't use rules, then if you just
then there's no issue. I understand.
There's no issue.
And I assume that graph plot is fine.
And I view rule as sort of it's a courtesy issue to allow rule. The fully correct thing is edges, undirected edge, directed edge.
Right. Can I see how you do this in the modern world? What is the way to do that?
Okay, let's try. Vertex shape function.
Mm-hmm.
And probably copy the same shape function because it's called.
No, I don't want to do that. I want to do this.
Oh, right.
No, that won't work. Do we have a function that allows you to put the labels in circles?
Yes.
Okay. My second question is, why is that turning red? And that's probably is that just documentation? Not
documentation.
Documentation.
Okay. All right. Fine. But this is a nice style, and it would be really good to be able to have that style be easy to get to. Right? If we can name it.
Right.
But do we have that yet? I mean, do we have a collection of vertex shape function named vertex shape functions?
Yes.
Or is that a vertex style or something?
We have a set of vertex shape function, but they don't include by default labeling. So.
But you can put labels. You can place, labels in the center.
But I think we should do that. I mean, we should have some. I would suggest having some that include labeling.
I think it sounds more like a theme because it combines multiple options.
You're right. You're right. So do we have themes for these yet?
Yes, we have I mean, we have the standard plot themes plus 2 specific themes for graph.
What specific ones do we have? By the way, that autocomplete is less than wonderful, I think. I think we should customize that autocomplete for graphs, especially if there are some additional themes.
Yes, I think we do that already for graph. We'll do the same for graph plot.
Okay. So are you saying there? Yes, very nice. So where is the where are the special ones?
So if you extend that menu, I think we have classic by the last two.
I think if this is important, if whatever large graph is important, is it important?
Yes, when you reach a threshold of 1,000 vertices and edges, then we change. We instead of drawing circle, we switch to point and we change the color and such.
Why do we change the color when the graph gets big?
Because with the default color is almost invisible, I think, if I remember correctly.
Let's look at that for a second. I don't understand why we go from blue to orange. It just seems crazy to me, in the naively. Okay, so if I say something like this, okay, I'm still blue. How do I go? I mean, I'm fine being blue here.
Specifying your plot theme.
Okay, but wait a minute. Okay, I see. This is a choice to go to a different color. Okay, that makes sense to me. Sorry, I thought you meant we were defaultly going.
Oh no.
To. I see. Well, the point is to have more contrast between the edges and the vertices.
The vertices, yes.
Oh, that makes perfect sense. But I think you should put it higher up in the autocomplete menu. Okay, we have something from the live stream here. Somebody with a piece of code. Let's run it. That's perfectly nice. Vertex label. Well, that's actually a pretty civilized piece of code. That seems to work quite nicely. Yeah, good. I mean, I hope that's documented properly.
It is.
Good. Okay, let's move on then. All right, was there something that was unconcluded here? I mean, there's the self-loop style thing, whether to, may I make the suggestion that if it sets a what we could do, an alternative to what you're doing right now, is generate a message and say, use plot theme arrow classic if you want the old behavior, and expect that we are largely deprecating those options.
Okay.
Rather than automatically revert to the old behavior. What do you think, Roger?
I agree with you. I think we need to sort of, I want to just softly nudge them forward, and then we can get more. Once we have it running for a version or two, we can be more vocal.
Fine. Okay, onward. We are rewriting estate tax law or something here with property inheritance. Never mind. Sorry. Okay, what are we doing here? So this has to do with.
So this one that uses inherited for the vertex coordinates.
Right.
Okay. You can specify that you shouldn't inherit them.
Well, now what are we doing? What did it do before?
It wouldn't. It did never inherit them. It would regenerate.
Are you sure this is the right default? I really am not convinced this is the right default at all. I think this is great behavior. I would really like to see this being the default, and then this being something you can set. I just think this case is a rare case where it actually looks reasonable. There are plenty.
No, we have a lot of. This is one where we have a lot of reports where people want this behavior.
Really?
Yes. So that was one thing we, for the last 5 years, that was one of the key complaints where people want, that we preserve those properties as well as the layout.
Can we really change this at this point? I mean, isn't there a lot of stuff where I mean, preserving the layout, I understand.
But that is the layout.
Well, no. Okay, if I say in here, for example, let's say I say graph, and I say, vertex labeling goes to automatic, for example, vertex labels. Okay, fine, but that's very inelegant. Why did it overprint there? Why does it not know to go outside?
Yeah, we are working on that. That's actually a project we are doing now to fix the labeling.
I don't know. I'd be curious, since we obviously have some users of our graph functionality on the live stream. I'd be interested in people's opinion there about whether this is a good default. I'm concerned. Don't you get into stupid situations in some cases?
Well, that's why we went manually for function by function to actually pick the
No, I understand, but specifically for this, for subgraphs.
What defines stupid?
I don't know.
No, I mean,
why is automatic inherited? I would have thought vertex coordinates to automatic would reset the vertex coordinates.
No, so this is an inheritance. So the default value, if you do option of subgraph, the default value of vertex coordinate is automatic. So we define automatically what to pick. So we pick that we are going to do the inheritance. We can switch it back off to none. So if you say none, then we don't inherit the vertex coordinate.
We have an interesting comment from our live stream here, which I will paste into our current notebook. So a point made was that if you have edge weights, it's obviously a good idea to inherit them. But this is a good point.
Yes, but that's a good point, and we are aware of that. And that's why we make the decision. As even the default graph, when we hit a certain threshold, we make the right decision to compute the vertex coordinate or not, because that's an expensive thing.
Yeah, but you have to, no, but hold on a second. You have to compute the vertex coordinates if you're going to pull them over to the subgraph. You have to have computed them beforehand for the whole graph. So even if the subgraph is just 3 elements, if the original graph had 1 million elements, you have to compute the layout before you can find the elements, but find those 3 elements.
Yes.
Seems like a very bad idea.
No, that was actually one of the key issues. We haven't actually done those properties for the last 5 years. So we needed to check which function it would be costly and what the user.
But why isn't this very costly to move? I mean, I have to say, I think the default for vertex coordinates should be none, or what I think the setting for automatic should be, which is recompute them. I think inherited should be a thing you have to set. I just don't think people expect this. This denies graph theory, basically. This is saying it matters what the layout of the vertices is, which is just not what graph theory is about. I mean, what are you going to do when you do a graph union? You're not going to do this. I think this is a mistake. I think the default should be what it has been, which is, recompute the coordinates. But I think this is very useful, what you have here, of being able to inherit the coordinates.
So we're just arguing about subgraph.
We're arguing about subgraph. We're arguing about the default for vertex coordinates for subgraph. And I strongly think that it should be automatic, which should mean recompute them.
Okay.
Okay, that's what I think. So what other ones? I mean, edge weights, obviously we want to move over. That would be crazy not to move the edge weights to the subgraph. But I think anything that is attached to the graph, so to speak, like edge weights, makes sense. Anything that is a kind of a meta layer, like the embedding in space should not be moved over. That's my
everything apart from the pure connectivity is meta.
No, but well, okay.
Styles, shapes, everything.
Right. Maybe it's just the embedding that I'm making a fuss about. You're right. We do want to move over. If one of those vertices was colored red, we want to move that over to the subgraph.
But the embedding is slightly tricky because somebody can specify the vertex coordinate explicitly in the polygon, sorry, in the graph, right? So now automatic, what do? We just disregard them. And also in the future, we are planning to do the constraint layout, right? Where somebody give partial vertex coordinate and then we...
Is that still not? I thought that was done now. I thought you did that.
I mean, the base code for Spring Electrical is there, but it's more complicated. Actually, we have to do that for all the layout and all the stuff.
We have many layouts.
Okay, so wait a minute. The point that you're making, which I don't disagree with, is if somebody explicitly set the coordinates, then I'm much more partial to moving them over, to inheriting them. The case that I don't like is the case where the coordinates were found automatically.
Okay.
But is that doable? Is there a way to do that? To move over only the ones that were set explicitly, or do you not know which ones were set explicitly?
We know. We can do that.
Okay, then that's what I think the default should be. And perhaps what that should be, so automatic then should mean move over ones that were set explicitly, don't move over the ones that were not, and I guess none, although I think it's a little odd, means kind of move over none of them, and inherited means move over all of them. Make sense?
Yes.
Okay, let's take a look at some of these other. Okay, so let's all right, so wait a minute. The inherited, yeah, I get it. But now, okay, so you understand what I'm claiming about automatic. Automatic would typically mean, inherit if it was inherit if it was given by the user, don't inherit if it was auto-generated.
Yes.
But now let's look at some of these other properties. So you're saying, okay, so if I look at the other properties that can exist in a graph, what should I understand about what gets sort of what annotations get moved over, and what happens in like a graph union?
Right. So the NRE operation, those are the only one where, I mean, we have to make a choice.
So
for graph, so for graph union, currently we just decided to. So that's the union, not the disjoint union, right? So for the disjoint union, that's obvious. We carry everything because that's disjoint. For the union, we pick the first graph. That's the current behavior.
Which is similar to what we do in show with multiple plots and things, right?
Yes.
It's not the most wonderful thing to pick. Okay, so hold on a second. In a graph union, okay, first question is, how do you relabel the vertices in a graph union? Am I confused? I mean, if I take this graph and I say graph union of that graph, comma, that graph, oh boy. So is that, I don't understand what just happened there.
So there is two union, graph union and graph disjoint union. So this union essentially does the union of the vertices, right? So
because I had those vertex label names, you're saying I got this. So if I were to do, for example, here, I would say complete graph of 8 or something, okay? And then I was to put that in there, you're telling me I would just get a complete graph of 8 elements because that thing there already exists. That is really confusing. So if I were to relabel that, how do I relabel the vertices here? Is there a good way to do that? there a good way to relabel the vertices?
Let's see.
Graph reindex.
Do we have that?
Well, I think you can do a vertex replace, and then you just change one to a specific name, I think.
Okay, so okay. It's nice that it didn't lose the idea that it was keeping vertex labeling. I mean, maybe that wasn't profound that it didn't lose that idea. Okay, so let's try this guy. Okay, wait a minute. What the heck is that doing? Now I'm even more confused. What did that just do?
Because essentially now you have the first graph, all the vertices start at above 10 and the other one at 8, so they are disjoint.
How did it manage to have a vertex in the middle there? What's going on?
So wait a minute, you skipped 0 in your replace. In your table for replace, vertex replace?
There isn't a 0. There isn't a 0.
Oh.
Okay, let's get labeling here. Let's do in this case here. How do I? So the other thing that happened is it lost the labeling of that first graph.
Right. First of all, I think it's just a change of the layout. It didn't preserve the layout because there are two different layouts. The complete graph uses a circular embedding layout. Since the graph are no longer circular.
I see. Okay, all right. So let's take a look at what it did here. Vertex labels arrow automatic. Okay, you're right. So okay, so that but okay. So you're saying that when I do graph union, it matters. It's doing it based on the actual labels of the vertices.
Yes.
Right? Okay.
Yes. On the names, we call them names.
Yeah.
The labels is something else.
Yeah. Okay. Right. I get it. Okay. So the question is now, if one of these graphs was, so why is there a problem here? Unless if the thing attaches. Okay. So here, if I goes to I plus 4, for example, here, and then I put that guy in, then I will have something where I've got a tangled web, right? Okay, so now the issue is, so now I'm actually confused here because that had vertex labeling and that didn't, and yet this thing didn't end up with vertex labeling in the end. But that confuses me.
Yeah, for the graph union, we haven't, since we are still deciding, we haven't really fully implemented the inheritance yet.
Okay, fine. But what should we do? I mean, arguably, what on earth should we do? Because if we've got two nodes, I mean, this is, again, a calculus of annotations problem. Because we could have 2 8 nodes, and one of them is blue in the first graph, and it's green in the second graph. What should we do?
Well, I think what we don't want to do right now, but what we could do eventually, if this becomes a real issue, is to design a resolving function, something that you have to supply as a user.
Yeah, well, I mean, it's analogous to a key collision function.
Right.
In an association.
Yes.
Well, I do think that that's a sensible thing to do eventually.
But I kind of don't want to go there now unless
I agree.
Turns out
we're not ready. We're not ready for that right now. I think as we think about graph replacements and things, as we think about things that necessarily rename, like a graph replacement is going to be adding vertices to a graph with random numbers in them. And for example, do we have a way to recanonicalize the labels of a graph?
Yes.
What's it called?
What is it called? Graph reindex, graph.
You will canonicalize the label.
Yeah.
So that means an arbitrary property through the annotation framework, right? Annotation value and such.
Canonical graph.
That's what it's called. Okay, so for example, if I did this one, well, that one doesn't have any weird vertices. Okay, so canonical graph just means relabel. So if I took that graph, well, here, if I say canonical graph on this, and this is now going to be another question about so canonical graph of that. Okay, it lost the vertices, vertex labels. Why?
Well, just specify that you want them.
No, but I had them here. So why didn't I have them here?
Oh, I see. Inheritance-wise.
Yes. I mean, but this may be explicit. Go ahead. It may be that the argument is canonical draft just rewrote those labels. But the question is, what happened here of vertex labeling arrow automatic, or was it specific vertex labeling when this is very confusing?
And the case of canonical graph is different, and I think we haven't yet included it there because canonical graph gives you a graph which is canonical. So if you have two graphs which are isomorphic, you get the same canonical graph, right?
Yes.
And you hope that our equal and the rest will work automatically. If we start to introduce inheritance of label there automatically, that means somebody will give you two graphs which are isomorphic, but you'll return two different results.
Oh, you're right. You're right, Charles.
That's super confusing. Yeah, I understand. But so one question would be partial canonicalization, like, for example, renumbering vertices but not changing their properties, because that seems useful to me.
Right, so one idea was like for the graph union there, actually, if I think we actually do that. So the option is property, right, or what we're going to call now annotations, is set up to none. So that means we don't. See, if the user wants it, then he will set up that property or the inheritance, the option.
But wait a minute, in canonical graph.
No, I think we haven't yet done that for canonical graph. We have done that for graph union. So if you do option of graph union, you see that the property is set to none.
Properties. Wait a minute. So that would be the future in the options version of annotations. It's called annotations and it's an option, correct?
Yes. Annotation roles, yes.
By the way, why on earth are these not in alphabetical order?
Yeah, there's something. It should be.
Okay, a baguette. By the way, I'm just surprised, and Andrea, I think, is on this call. Could you make sure that the testing folk check that? I mean, something we used to check years ago, that the default options are in alphabetical order. I have no idea how that ever got not to happen, but in any case, our user on the live stream is pointing out that index graph apparently.
Oh, that's what I was having. That's what I was looking for.
It's very good that we have. Thank you. So if I take that and I say index graph of that, now drum roll, it's going to lose the labels. Okay, so what can be done about this? What should be done about this? So if those labels were explicitly given, right, then it should lose them, presumably, right? But if those labels, you get what I'm saying? I mean, but those labels being automatic, in other words, if what this had in it was vertex labeling, and I bet it does have that, if I say options of that. Oh, wait a minute. Well, it doesn't give vertex. Why doesn't it give vertex labels? Oh, automatic. Oh, because that's the actual things in the graph. I'm so confused here. So I claim that vertex labels are automatic, should be inherited here. See what I'm saying?
Yes.
Do you agree with me?
Yes.
Okay. So again, let's go through it again. If the setting is automatic, well, okay, so if vertex labels in the index graph, okay, if I said vertex labels arrow inherited in the index graph, what would it do?
So if the graph have a vertex label set, I mean, inherited, you will just essentially get what is originally from the graph. So if it's automatic, you will probably pick the name. So that means if somebody generates a graph where the label are, some random string or image, when you apply index graph, the label will change to numbers.
Yeah, that's right, I think. Right, but if we say vertex labels arrow inherited here, I love this bug, whatever the heck it is. I wonder what that says. Okay, let's not even worry about that. But you agree that this should come out. That should do something, yes or no?
Yes, should.
Okay, all right, fine. Okay. All right, so question. So the n-ary functions, I mean, there's clearly some more of this to figure out. I mean, is there a big table of what you've actually done in terms of inheritance for these things?
Yes, we have a list of so far 25 functions. A couple of them.
Could you send me that list? Could we take a quick look at that list?
Yes. Let's see.
Okay.
So
the live stream is pointing out that it's weird that they were not inherited because they say that usually they are. Well, that wasn't inherited now, so maybe it previously was inherited. Do you know?
No, it was not previously. Definitely sure.
Well, you're wrong. Look.
Okay.
Oh, but that's different than inherited. It says that the vertex. Oh, wait a minute. Vertex labels automatic.
Yeah. So somehow that moved over the options to that graph, and in the new case, you didn't move over the options to the graph.
No, but
yes, because correct. Because before we were doing pretty much that all in place, so it was skipping everything from the original graph. We didn't per se have an inheritance.
Person on the live stream points out index graph is one of the few functions that did preserve properties in previous versions, but now it doesn't. But we agree it should in this case, right?
Yes, it was not just yet implemented.
Okay, fine. All right, let's go on and look at the other things here.
I send you the list.
Okay, great. Okay, so what are we looking at here? So let's make this a little bigger. Okay, so these are all the functions. So for example, index graph is there.
Right.
Oh, graph power, that's a horrifying case. Find spanning tree. Well, that one, surely you want to keep edge weights and stuff like that when you find the spanning tree.
Right, because roughly is a subgraph, yes.
Okay, but the fact that it doesn't have a check mark just means what?
It's not done.
Yes. Or we probably haven't updated this. I think by the time Jan actually finish it, but it's probably implemented, I believe so.
Okay. So let's just take a look at these. What does Boolean graph do?
It's union, intersection, everything. It takes a Boolean function.
Oh, wow. I didn't even know it had that.
Any Boolean combination.
So I can NAND graphs.
Yes.
That's cool. That's interesting. So that, Roger, you're returning to your roots. This is binary relations somehow meets graphs in some way.
Yes.
Okay. It's interesting. Is it useful to NAND graphs together?
Don't know.
Okay.
I mean, NAND in particular, I don't think. I'm sure there is, NAND is a useful relation. So
okay.
And graphs, represent relations. So sure.
Okay. What about, let's see, when you have planar graph, what is simple graph and what's planar? What about planar graph? Does that keep? So clearly if you say planar graph, it's going to blow away any, oh, go ahead. What were you, I mean, because sometimes you could say planar graph and you could have given vertex coordinates, which are incompatible with it being a planar graph.
Yes.
So what happens in that case?
I think if I mean the graph needs first to be planar, right? Otherwise, it will fail. It's a purely constructor to to use the planar embedding.
Fair enough, right? But can't you say planar graph of a non-planar? I mean, if I say, can't you say planar graph to force the planar graph embedding?
Set it to false.
No, he says force it, but you can't. If it's not planar, you can't force it to be.
Well,
planar.
no, I understand that, but but listen. What I mean is, connectivity-wise, the graph is planar, but embedding-wise, the graph was forced to be non-planar. Get what I'm saying? In other words, it's rendered non-planarly, but it is by connectivity it is planar.
Right.
So then what happens with respect to inheritance?
The inheritance is independent of the layout, right? So we just draw it.
The inheritance of vertex coordinates is absolutely to do with layout.
No, so we have a precedence in in the documentation. So vertex coordinate take precedence over the graph layout. So if you specify the vertex coordinate, it overrides the graph layout.
Okay.
So if the vertex coordinate are automatic, then we use the layout or the graph layout option to determine how to draw the graph.
Okay. All right. Well, okay. So let's just keep going on this. There was a comment about neighborhood graph. So neighborhood graph, I would assume, inherits everything but it shouldn't inherit the coordinates, right? In the same way that subgraph shouldn't inherit the coordinates by default.
I think opinions are split around these things.
Yes.
Because we have a bunch of bug reports that want them inherited.
Well, I want the possibility of them being inherited.
Or some people were expecting, when you do a graph layout on a neighborhood to, to visually actually see that neighborhood. That's the only way you can identify it.
Look, neighborhood graph, except for the sufficiency issue, which seems rather horrifying, neighborhood graph, I can see more of an argument for that. Subgraph, I really don't see the argument. What other cases are there?
We'll have the possibility in both. We're just discussing defaults, right?
Yeah, we're discussing the default. Okay, and so the question is, should neighborhood graph, I mean, I would argue perhaps that the efficiency argument would would tip it over. So does neighborhood graph preserve the embedding right now?
No.
Was
I
it?
mean, do you mean in the new X?
No. I mean in version 11.3.
No.
Okay. So I don't think it should. I don't think it should by default. I think you should set it. I just think, it denies the graphiness of a graph to by default move over this embedding.
We have a sliding scale of uses. There's a lot of people that use graphs mainly for illustrations.
Actually, it's the opposite. I think in neighborhood graph, you actually preserve it.
Really?
Currently, yes. That's what the user on a live stream was indicating.
Well, you remember we did that little experiment that in some function where we behaved that, I mean, we thought that we should preserve it, we kept it, right? Well,
but at that time we didn't have the tooling to do it more generally for this inheritance.
All right, listen, there was a couple this version, if we put it in neighborhood graph right now, leave the default the way it is right now. Fair?
Yep.
Oh boy, we have a bunch of comments on our live stream about all sorts of things. Comment about undirected graph. How do we preserve edge weights if two reciprocal edges are merged into one? That's a good question. I mean, how do you combine the edge weights if you have A goes to B has an edge weight and B goes to A has an edge weight? What do we do? I mean, obviously it needs a combiner function for that case.
Yes.
But what is it that will cause those two edges to be combined? What function causes those to be combined? Is it undirected graph or what? that undirected graph will take those two edges and smoosh them into one. But does it do the right thing with the edge weights?
Well, that's why by default, some of those functions which are pure, topological based on the structure of the graph, at the time we just drop those properties. The same apply for sample graph. If you have a graph with multiple edges and you call sample graph, how are you going to preserve those properties, right? The label, the weight. And
I get it.
And my point of view is depend on the use, the property are specific. They are user property or general property. The best is to turn them off and then the user precise that.
No, I understand. But the point being made is if you say make an undirected graph out of a directed graph with edge weights, there is an argument that there should be a combiner function in the undirected graph that says what to do with the edge weights.
Yes, I agree.
Or in general, what to do with, if they're colored edges and things. So obviously we're not getting that for 12.0, but that seems, you agree that that's a reasonable suggestion.
Yes, that's in the plan, yeah.
Okay. Next comment here. Same question with simple graph. Yeah, okay. That was what you just added. Sometimes you do need to preserve layout of subgraphs. We agree. And that's why there's an option being proposed to make that possible. For example, what about, what about cities? Well, the point is that, as we just said, the default, if you gave the coordinates explicitly, then they would be preserved. It's only if the graph was automatically laid out at the beginning, which wouldn't be the case for cities.
So I think there's a really strong case in both, okay? And the reports that we've seen are mostly that they want it because they didn't have it. So obviously they didn't report that it was, it did what they wanted.
Correct, yeah.
Right.
Right. I think, right, so a comment also being made here, any geograph. By the way, we haven't, we intend to have a function called geograph in the future that gets road networks and all kinds of things like that, but we don't have that yet. And clearly in that case, okay, so let's talk about that case for a second, all right? Imagine that, okay, so a geograph, yeah, that will work correctly with our defaults. A geograph would have explicitly set vertex coordinates, right? And so then the defaults that we're proposing here would be correct. Okay, so they're saying more messages below. I'd like to see the messages. So the comments, again, in 11.3, neighborhood graph does preserve vertex coordinates. That was, yeah, right. So this is the point I think you're making on the live stream before, is that, there's an efficiency hit for doing that. And, this is kind of a complicated issue, right? Is neighborhood graph, again, okay, first comment. We all agree that if you explicitly set the coordinates in your graph, then preserve them. The argument is about if you didn't explicitly set the coordinates, what happens? What happens what happens? Does it take the automatically generated coordinates or not? Okay, are there more of these?
Our automatically generated coordinates are sometimes very carefully chosen. Like we have custom layouts that does circles and bipartite, and
sure,
they're not just sort of spring electrical.
I understand. You're making the argument that they are the finest coordinates and they should be preserved at all costs.
No, I'm just saying that some of them, when you get a complete graph, it looks like what you expect a complete graph to look like, and
sure.
that's not by accident, and it's
no, I understand, but
certainly not spring electrical that did that.
No, I realize that, but I mean, your point is, I think I correctly represented your point. You're saying these coordinates could have taken a lot of trouble to make.
Yes,
and yes. So that raises another possibility. Okay. Oh boy, that's another case, right? Because what you're describing is, what if you used I don't believe in this case. Okay, so what happens? Okay, you take two graphs, right? Okay, so I'm assuming that the type of embedding, the embedding generator, whatever it is, the graph layout option, that I'm assuming that is, okay, what happens to the inheritance of that? So in other words, let's say you said, I want a layered layout, okay? And then you change the graph in some way. Does the newly produced graph, maybe it's a subgraph, I think is off we obviously shouldn't be, okay. Question, let's say an original graph is a layered layout. Then you take a subgraph. Is the subgraph also layered layout or not? Do you get what I'm asking?
Yeah, Charles, I think it is already now, because it just the way that the general automation work, it would pick a layered layout anyway.
Right, you will just carry that property.
Okay, but so then let me.
But is it the property that's carried, or is it the fact that it's, well,
it might be in that for graph theoretic reasons. It might be something.
Right, that's what I'm thinking.
Right, but I mean, then I can blow that away.
Layered before, then the subgraph is going to preserve that property.
No, I understand, but so I can blow that away. Let me do a graph power or something like that. I don't know offhand, but I would guess I can easily blow away whatever you give me there. I can blow it away by doing something different.
Sure.
Right. So then the question is, does it then sort of, inherit through the layering layout or not? I mean, that's a different case. That's of the case that you already discussed with explicit coordinates. That's one thing. But let's say you set, it is not clear to me what it should do, right? In other words,
so when we went through this whole thing of updating, what we found out that it was per function. That was one thing, and it's hard to have a general policy. One example is the spamming tree, right?
Mm-hmm.
Somebody gives you a graph with a layout, right? Whatever layout, spring electrical, and a spamming tree, right? What do you want to generate? Usually what somebody would expect is to see something which have a structure of a tree.
Yes, fair enough. Yes,
but you could also expect it to be,
look like the original graph, which might
right.
not look like a tree at all.
Exactly.
Right? And that's exactly where vertex coordinates are inherited versus vertex coordinates. In other words, if the thing was, I think what we're talking about, the default there is correct, but I think this is a new case, which is you've specified a type of layout method. Should you inherit that? And you're arguing that in a few specific cases, I mean, like the layering property, sure, you can inherit that, but circular embeddings or something, who knows whether you should inherit that? I tend to think you probably shouldn't inherit the layout by default. The layout type by default. I'm not sure. I don't know. Do you think it's function dependent?
Yeah, I think it's function dependent.
Well, so perhaps we should see in this picture, there should be a bigger table that indicates, which also might be good for documentation somewhere, but indicates what is preserved in which function. You must know that, right?
Yes.
Okay. On our live streams, it's pointed out that combining edge weights should be an option edge weight combiner. Yes, I agree. I mean, that's presumably what you have in mind, something like that. For the case of going from a directed to an undirected graph, for instance. All right, let's try to get to the end of the agenda. Maybe we'll come back to this. I mean, this is clearly a very complicated issue. What should be, and it will be good to try. Do you have that big table of everything?
No, unfortunately, no. We'll build one.
Yeah, build one, and let's see it. I think it'd be worth doing another iteration on this, because I think it's the more we can get these defaults right first time, the better off we are. Okay, let's keep going here. Small additions. Yeah, and also pointed out that we need a vertex property combiner for vertex contract. Agreed. Okay, smaller additions. Entity integration. Graph entities. Oh, that's nice. So in other words, if I say, what's an example of a graph? I don't know, Peterson graph. Is that even the right spelling? Yes. So if I say, what would I say? If I say something like graph power, I don't know what I'm doing here, but let's say that, comma 2.
No, probably just do graph. We have to finish the full integration. Currently, we did the integration for some of the function.
I see. Okay, so that's if I just do that. Help. Oh, okay. Fine. Beautiful. Okay. But now if I take that, what does this? Lovely. Okay, entity. Okay, gravity embedding. You requested layout. What does that do?
Just open it. The examples below.
What does that do? Where's the gravity?
Well, it's
in orbit. Where's the? Sorry, I don't understand. Go on.
Well, so essentially it computes the graph center. So we find the vertex center and then we apply the spring electrical, which that's why it's a gravity, roughly speaking, embedding.
Wait. Where's the gravity? Are we talking gravity as in attraction to a center of mass of some kind, or what?
Yes, attraction to a center of mass. So we compute a center of mass, in this case, a graph center or something close. Okay. And then we have attractive force attached to every vertex.
And why are the vertices, why are the edges curved?
Oh, just to make it look nice. So that was coming from a paper, if you do remember, from Bob.
Okay, so hold on. If I take this thing and I say, let's do this. Sploff. Okay, all right. So then I go here. Let me get rid of all this stuff and just I just want to see the default. Okay. All right. And now what you're saying is if I just do G, well, I could just do G itself. So I'm fairly confused here about what's happening.
No, it's just one new layout. It's not a default layout. It's just
okay. But I still want to know what does the curviness mean? I mean, that seems like an independent thing, whether it's curved, and then I don't understand what causes it. I mean, like that edge seems like it just could be a straight edge.
Yes, I mean, layout is just look, right? What look nice? It seems like when they are curved, they look nice.
Okay, fine, but I mean, could we could in spring electrical we could have curves as well?
Sure.
Yes.
Is it worth having a curved spring electrical?
No, it's just edge shape function goes to B spline.
It seems to me that the name gravity embedding is rather generic for this, and it would seem to me more likely that a name like that would mean something related to falling down to the ground rather than some kind of in-orbit gravity type thing.
Yeah.
Is there another name we could come up with for this? It just seems like it's very hard to guess what this would do.
I mean, they're all quite hard to guess.
Okay, well, let me give you my version.
I mean, I can tell you that the names used in other software is even worse, because they used like the names of people, unless you have that standard joke list.
No, I understand, but I would have thought gravity embedding would be more like make a mobile out of this thing with pieces of wire and have it hang down.
Oh.
Which I think would be a reasonable embedding. I mean, there clearly is an embedding that is, imagine these things are beams, members of some kind, and hang it from somewhere.
It's actually close, right? In 3D, that's roughly the same if you specify the center point.
Let me see if I believe you. Really?
Yeah, the center seems to be in the middle there.
Can I specify how would I pick? This doesn't look at all like, I mean, what I was thinking, okay, but it's being attracted to the center, right? I'm so confused. But I mean, if I pick it up from this guy here, right?
Yes.
And those beams have a certain, I don't know, Young's modulus, whatever. There's more than that actually, but I mean, this is quite beautiful looking, but I still don't understand. I don't understand okay, you're claiming that what I'm saying about picking it up from one thing is sort of what it's doing. Is that right?
Yes, if we give a control on the actual that point, if you can specify that, roughly that.
So we automatically pick the center point and have them gravitate to that.
Okay, but it's gravity to that point rather than an external force.
Yes.
Right. I mean, so what I'm saying is if there's an ambient gravity field, as opposed to,
we could do experiments with another version of this that says it gives it a parameter and you specify
the acceleration due to gravity, so to speak.
Well, yeah, but like, I mean,
all right, okay.
All of these things require quite a bit of experimentation.
Right. All right. I agree that this is a pretty nice layout. This is interesting. All right. If you think gravity layout is, gravity embedding is good enough as a description, okay with me. But it troubles me a bit. As you say, it's obscure to know what these are. Yeah, okay. On the live stream, somebody's pointing out, shouldn't edge curvature help visually distinguish close parallel edges? They should repel and have opposite curvature. Is that what's happening here?
No, not really. We can't do that. We haven't yet really.
But in the future, we might expect that a multigraph would get things that bulge out, but I mean, it already does bulge, doesn't it?
Yes.
Yes, but
that's not in this embedding. I mean, that's not the nature. Oops. I mean, so you're talking about
no, that's the point. I can't guarantee that will happen. Yeah, for that, yes.
Right, but in the case of this gravity embedding, it chose to flip it around, but nothing more.
But it's grid embedding. It's not gravity embedding.
That's because I auto-completed wrong.
Right, because
who knows what that's doing? Okay, so that's just horrifying, and we don't know what's happening there. But we can't expect every embedding to do well in every situation.
Right.
Okay. Edge weight. Vertex weighted graph.
Well, it's just user have been requesting that we have a weighted graph, but you don't know if it's the vertex or the edge which have the weight. So they need a function, a Q function to return. I mean,
it's a truly trivial thing, Stephen, but it's kind of more programming utility wise.
Is it useful for patterns and things?
Yeah, exactly. So you're going to ask for a pattern, @ edge weighted graph Q.
Mm-hmm.
It's that exactly utility.
Okay. Well, a lot of lovely functionality. Clearly, this inheritance business is complicated. It'd be nice to see the full thing, but a lot of great stuff here. And how big can we do? How big a graph can we reasonably do?
For plotting? I mean, for computation, we've done with billions of nodes.
Really? Billions?
Yeah.
So if I say,
but then the algorithms of what the operations you do on them, they vary greatly in complexity. Some are very easy, some are super hard.
So did that actually compute a new graph?
Yes.
Yes.
That was pretty spiffy. But now I see that's not rendering by default.
Yeah, we have a threshold where we stop the runway.
But if I say graph plot, no.
Is in your version, we are going to fix it.
Okay, all right, fine. So graph plot is going to always do it.
Yes, that's the plan.
Okay. Well, wonderful stuff. Hey, thanks to folks on live stream. Also, very, very useful comments today. Much appreciated. And I hope you like the new functionality. And thanks, Roger, Charles, etc. And I guess talk to you soon. I'm looking forward to our next next meeting.
Okay.
Okay.
Thank you.
See you.
Thank you very much.
Okay. Bye.
Bye.